Hi everyone, we are presenting our project Succour. This project is done at Assistive Technology Lab in Sri Vishnu Engineering College for Women under the technical collaboration with UMass Lowell University, USA, under the guidance of Mr.E.R.Praveen Kumar sir of the TIIC department and K.Ramu of IT department. Old age is integral part of life, which is unavoidable, unwelcome, and problem-ridden phase of our life. Nowadays, the number of elderly people living in old age homes or at care centers is increasing. It is not essential that they lead a comfortable life there. So, in order to assist the elderly and even physically challenged people, we thought of providing automation to certain things at home or at care centers. This form of home automation comes under category of assistive domestics, which is used for giving safe and comfortable living for elderly people. There are already certain projects similar to automatic doors like magnetic doors or exist. The problems with magnetic doors are after a prolonged use, they may lose their magnetic property. Other type is remote control doors, whereas remote control doors are not much useful for physically challenged peoples. The doors are not much reliable and not useful for elderly people, and also we can find this type of automatic doors usually at shopping malls, theaters, but not at homes. So, in order to overcome existing problems and make it user-friendly and reliable, our proposed solution is our project Succour, which means helping aid to people at times of need, and is human motion sensed automatic door and room light control system. Major components used in this project are the microcontroller used here is MSB430G2553. These MSB430G series are ultra low power mixed signal microcontroller. Application of this microcontroller includes low cost sensor systems. We have chosen this as it serves the purpose of microcontroller being used in automation applications. This is passive infrared sensor and is an electronic sensor that measures infrared radiating from objects in its field of view. These are small, inexpensive, low power and easy to use. LDR is a light dependent resistor and is also a light control variable resistor which is used in light or dark sensor circuits. Condenser microphone is a acoustic to electrical transducers or sensor that converts sound in air into electrical signal. L293D is a H-bridge motor driven module. With this module, two DC motors can be driven simultaneously both in forward and reverse directions. Relay. Relay is an electrically operated switch which provides complete electrical isolation between control and controlled circuits. Here we are using 12 volts DC motor for prototype in order to rotate the door.
And here comes a system level block diagram. Here we are using PII sensors which detect the human presence by the difference in the IR radiations which they produce. And next is a dark detecting circuit where we are using an LDR to detect the dark. And next is a sound sensor where we are using a condensed microphone in order to detect the sound. These two circuits, dark detecting circuit and the sound sensor, gives analog signals which are given to a comparator LM324, which is a quad comparator, and converts this into digital signals which are being given as input signals to the microcontroller MSP430G2553. This MSP430G2553 is programmed using Code Composer Studio in C. And next is L293D H-bridge module, which acts as interfacing unit between the microcontroller and the DC motor. And next is a relay, which acts as an interfacing unit between the microcontroller and the bulb. Here, there are two PII sensors we are using. The first PII sensor is present outside of the room on the door, and second PII sensor is present inside the room. So, whenever the first PI sensor detects a signal, which is already a digital signal being fed to the MSP 430G2553, the microcontroller is programmed in such a way that the motor is being operated such that the door opens, waits for the person till he enters the room, and then closes. And next, if the second sensor is being detected, it means that the person wants to leave the room. So the microcontroller is programmed such that it opens and waits for the person till he goes out and then closes. So this is in the case of morning. And now if it is in the case of night, along with the PI sensor, the dark detecting circuit will be active. So when the person is outside and when it is night, both these signals are active and being fed to the microcontroller. So the microcontroller is programmed such that as the door opens, the light will turn on automatically and then waits for the person till he enters the room and then the door closes. So now when the person is inside the room and if he wants to turn the light on or off, he can produce a sound which is being fed to the microcontroller, where the microcontroller takes care of the light to be switch on or switch off. Here is a CAD design that we have done considering the real-time measurements of the room, and with the help of the CAD design, we have known the placements of the light, the sensors, the motor and the LDR. This is the working demonstration of our project, and this is our prototype. Whenever there is a human presence, the door opens, waits for the person till he enters the room, and then closes. This is the LDR, which is used for the dark detection. Whenever there is a dark, the light turns on automatically. And now, when the person is inside the room and if he wants to turn off the light, he can produce a clap sound. And again, whenever the person wants to turn on the light, he can produce a clap sound and turn on the light. Thus, the working demonstration of our project is being explained, where the automation of the door and room lights are being controlled with the help of a microcontroller. And also, there is a further extension of our project where we can automate even other things like home appliances like fan, television, and air conditioner, etc. Finally, we thank our management for giving this opportunity of working with real-time environment projects and encouraging us to come up with more innovative ideas. Thank you.